Hello and welcome to Chapter 11, Regular Expressions from the book Python for Informatics Exploring Information. As always, these slides are copyright Creative Commons attribution, as well as the audio and the video that you're watching or listening to right now. And so regular expressions are an interesting thing. You've seen from in the chapters up till now, I've had a singular focus on sort of pulling information out of data, raw data, this mailbox file that perhaps you're getting tired of already. But it's a lot of fun because I can have you go look for something and pick it out, and you're doing something that would be really painful to do sort of by hand. And while it's not all of computing, I mean, there's games and there's things like weather computations that do calculations. Pulling and extracting data out is a big part of computing. And so there's actually a library that's built specifically to do this. And if you start doing a few finds and slicing, it gets kind of long after a while. And that's like Split, for example, really saved us a lot of time. But sometimes the data that you're looking for is a little more sophisticated than broken into spaces or colons or something like that. And you just want to tell something to go find, I see what I want, and I see where it's embedded in the string, go get it for me. And regular expressions are themselves a programming language. They're like a really smart wildcard for searching. So we've used wildcards in various things in search, but they're a really smart version of a wildcard. And so regular expressions are quite powerful, and they're very cryptic. And as a matter of fact, you don't even need to learn them if you don't feel like it, right? I've got this little guide. I need a guide for myself when I do regular expressions. It sometimes takes me a few minutes to write a regular expression to do exactly what I want. So in a way, writing a regular expression is like writing a program. It's highly specialized to searching and extracting data from strings, but it's like writing a program, and it takes a while to get it right, and you kind of have to change this. What about a slash there? And so but they actually are kind of fun, and they're a great way to sort of exchange little program snippets to say, oh yeah, I'm looking for this. Oh, here's a little regular expression you might try, and then so they're like programs themselves. It is this language of marker characters. So when we look for regular expressions, some characters like ABC have meaning as ABC, but some characters like caret or $sign mean the beginning of the line or at the end of the line. And so we encode in this string a program, basically. And so it's a rather old school language. It's from long time. It predates Python, which is over 20 years old. And so it also marks you as sort of a little cool, right? It's a distinct marking that makes it so that you know something other people don't, right? So you can know how to program, but if you know regular expressions, they'll be like, whoa, I tried to look at those and they're kind of tough. In a way, knowing regular expressions is kind of like a tattoo. So it's a casual Friday, and that's why I'm wearing a t-shirt today, and so I figured I would come in today in a t-shirt. But seeing how it's the first time I'm wearing a short sleeve shirt, it's also the first time I can show you my real tattoo here. So here's my real tattoo, and in the middle is Sakai, the open source learning management system, always close to my heart. And then you have the IMS logo, which is IMS Learning Tools Interoperability, which is a standard that means a lot to me. Blackboard, OLAT, Learning Objects, Angel, Moodle, Instructure, Genzabar, and Desire to Learn. I call this the ring of compliance because these are all of the first 6 or 7 learning management systems that complied with the IMS Learning Tools Interoperability Standard and Specification, which is something that I spent a lot of my life making work. So I figured I'd make a tattoo and just kind of part of my rough, tough image. And actually, regular expressions are indeed part of my rough, tough image because I'm down with regular expressions, and people are impressed with my regular expression knowledge. But as impressive as I am, I still need a cheat sheet. So I'll have a cheat sheet that you can download, hopefully, on the Python Learn website or whatever. And it doesn't have to be much. It's really just a kind of a crutch. And these are the characters that have special meaning, like caret or $sign match the beginning or end of line, respectively. So they're not really matching a $sign. They match. They mean something in our little mini string-like programming language. So, like many things that we do in Python going forward, once you want some sophisticated capability, it comes with Python, but it comes in the form of a library. And so the regular expression library, we have to say import RE at the beginning of our programs to import the regular expression library. Then we call re.search to say I'm looking for search from the regular expression library. There's two basic functions or two basic capabilities inside this library that we're going to look at. One is search that replaces find. It's like a smart find. And then find all is a combination of a smart find and automatic extraction. So we'll look at both of those in turn. And I'll do it by comparing them to existing Python that you kind of already should know at this point. So here's some code that's, say, looking for lines that have the string from colon in them, right? So we're going to open a file, we're going to strip the white space. If we hunt within line for from, if it's greater than or equal to 0, then we'll print it. And so this is just going to give us a number. If it's not found, it's -1. So it's only going to print the lines that have from in them. Here is the equivalent using regular expressions. So these two things are equivalent. So we have to import the library, like I mentioned before. And all the rest of it's the same. The if test is re.search. That says within the library re, call the search utility. And then pass in the string we're looking for and the line, the actual text we're looking in. So this is like look for from inside of line and return me a true or a false, whichever, depending on whether you find it or not. Now you might say, you just got done telling me that it was more dense. And the answer is there's a few more characters here, but we'll see in a second how you can quickly add more power to the regular expression. Find, you have to start adding more Python lines to make it more sophisticated, where in the regular expression you change the search string to give more of the direction of what you're looking for. And that's what we'll be doing pretty much, is changing the search string. So now if we wanted to switch to say, wait, we don't just want the from anywhere in the line, we want it to start with from. So we would change line.starts with from. And that's either going to be true or false, depending on whether or not the line starts with from. Now we do the same thing with regular expressions by changing the search string. So now we're in regular expressions. So this really just isn't a string. It's a string plus characters that are interpreted as commands by the regular expression library. So the caret, which is the first one on our little regular expression sheet, matches the beginning of the line. It's not actually a caret. So that says the first character, this two-character sequence, caret F, means F, but in column 1, in the first character of the line. So again, this is going to give us a true or a false if this regular expression matches. The beginning of the line, from colon, and it's the same as this. Does it start with from? So again, these two are equivalent. But you see the pattern where we're going to do something to this string using these characters that have meaning. Okay? So the next thing that's most commonly done, other than caret and $sign for the end of the line, is the wildcard characters. And so we've used wildcards possibly in like DOS, where we can use question mark or star in like a dir command, or dir.star.star if you're familiar with that, or even a Unix command like ls, star dot whatever. This is not how regular expressions work, and the problem is that dot is that it matches a single character in regular expressions. Asterisk means any number of times. So if I look at this and color code this to make a little more sense, the caret is actually kind of part of the regular expression programming language. Says I'm a virtual character matching the beginning of line. The X is a real character. The dot is part of the regular expression programming language, any character. Star is part of the regular expression programming that says the immediate previous character many times, 0 or more times, and then colon matches the colon. And so if you look at lines, these are the kinds of lines that will give me a true, because they start with an X, followed by some number of characters, followed by a colon. So that's true. Start with an X, followed by some number of characters, followed by a colon. Okay? And so that's basically how this works. And so in this 5-character string, there are, some of these things are like instructions, and some of them are the actual characters we're looking for. So the X and the colon are the characters we're looking for, and the caret, dot, and star are programming, right? They are logic that we're adding to the string. Okay, so let's say, for example, part of any of these things, and part of the stuff we've done so far, has to assume that the data is some level of being clean. And so the data that I've been giving you, mbox.txt, is not inconsistent, right? It doesn't have like too much weirdness in it. I'm not trying to trick you and mislead you. Although we've had situations where you sort of get a traceback because you think there's going to be 5 words, you grab a line, you break it, and there's only 2 words, and then you get a traceback because you're looking at the 5th word, or something like that. But if your data is less clean, or even if you just want to be real careful, you can fine-tune your matching. So here's that same match. Give me a character X followed by any number of characters followed by a colon, and that's what I'm looking for. Give me lines that match that pattern. So this X starts at any number of characters, colon, great. This any number of characters, great. Oh wait, and there's an email message that says X plane is 2 weeks behind schedule, colon 2 weeks. Well, the regular expression didn't know that dash made sense to you, and you just assumed that everything that started with a capital X had a dash after it. So X is what it starts with, any number of any character, and then a colon. So this becomes true. This may not make you happy, right? It may not be what you're looking for because you haven't been specific enough in your regular expression. So we can be more specific in our regular expression. So for example, this is a more specific regular expression. It still says start with an X as the first character, then a dash, that's a real character, not a... Then this next thing, instead of being a dot, it's backslash capital S. It's on the sheet. Whoa! It's not on the sheet. I lost the sheet. Come back, sheet. I lost the sheet. I can't live without my sheet. Backslash capital S means a non-white space character. So that means spaces won't match. And then I changed the asterisk, 0 or more times thing, to a plus. And that means 1 or more times. Here's a character, a non-white space. These two things kind of work together. A non-white space character at least 1 time, as many as we like. And then a colon. So if we look here, it starts with X dash, any number of non-white space characters, and ends in colon. Starts with X dash, any number of non-white space characters, ends in a colon. True, true. This one starts with an X, but doesn't start with an X dash. Oh, as a matter of fact, these characters are blanks, so this becomes a false. It does have an X and does have a colon and matched the previous one, but this one here is more specific. Okay, so it's more specific, and so it matches what you want. Now, it depends on what you're looking for. Maybe you do want this line, and so you're looking for X. I don't know. But if you want, you can be increasingly sophisticated in what you're looking for in a regular expression. So now, let's talk about extracting data. So everything we've done so far is it there or is it not? But it's really common once you find something that you want to break it into pieces. So we can combine the searching and the parsing into one statement. And instead of using search, which returns for us a true false, we are going to use find all. So in this example, I'm going to show you a new syntax. The square bracket in regular expression language means a way to list a set of characters. So this says, this is a single character that says, I want to match anything in the range 0 through 9. Plus means 1 or more of those. So that says, so this whole thing says 1 or more digits. That's a regular expression that says 1 or more digits. You can put other things inside here. You could put like, you could make a thing that says A, B, C, D, and that would say I'm going to match a single character that's A or B or C or D. Or you could say like, 1, 3, 5, 7, bracket. That's a single character that's either a 1 or a 3 or a 5 or a 7. So the bracket is a list of matching characters, and the dash inside the bracket means range. We'll see in a second that you can stick a not inside the bracket. It's on the sheet. So again, remember, in this little mini language, we are programming, right? We are giving instructions to the regular expression engine, as it were. Okay? So, if we do this, and here is an expression that says, I would like to find, things that are one or more digits. And so, so it's one or more digits, and so it's going to look through here, and it's going to find it as many times as it can. So there is one or more digits, there is one or more digits, and there is one or more digits. And so what find_all gives us back is a list of strings. So it found it, where do I match, where do I match, where it's looking the whole time, and then it says, oh, I've got it, 2, 1942. So it actually extracts the strings that match and gives you a Python list of strings. Python list of strings. Kind of like split, except it's like a super smart split, right? It's split, but I've directed it where to look for. And if, so here's an example of, that's the one I just did. Find me one or more digits and then extract them. So 2, 1942. Here I'm saying, using the same bracket syntax, to look for a single character, a capital A, E, I, O, or U, and one or more of those. And if you look, there are no uppercase vowels in my string. So it says, I'm going to find all the things that match A, E, I, O, U. So things like A would match, and, O, U would match. And so that's what we would get if they were in the string. But because there are none, we get an empty string. So even if there are none, you get an empty string. So it always returns a string. It may be a 0-length string, and that's what you'd have to check. Okay? Okay. Now, matching has this notion of greedy, where when you put one of these pluses or asterisks, it kind of has this outward pushing feeling, right? And so when you say, I'm looking for something that starts with an F at the beginning of the line, followed by one or more characters, followed by a colon, you can think of this as pushing outward. So if we look at a line here that has from colon using the colon character, it will try to expand, so it certainly has to match the F, and it's looking for a colon, any number of characters, but it's trying to make the string that matches as big as possible. So it skips over this colon and goes to that colon, and so the thing that we get is here. And so it ignored this and said, I will make as large a string as I can. So that's the plus that's doing it. Dot plus pushes. It's like, I got a colon, but is there another colon out there? So you can push it. Okay? So that's greedy matching. It can get you in some trouble, like being greedy in general. And both asterisk and plus sort of behave in a greedy way because they're 0 more or 1 or more characters, so they can sort of push outward. Okay? Now you can turn this off. It's a programming language. We can tweak it. Okay? And so we add a question mark. So this is a 3-character sequence now. So if you say dot plus question mark, that says 1 or more of any characters, push, but instead of being greedy and pushing as far as you can, this means stop at the first. Stop at the first. Oops. Stop at the first. I can never draw on this thing fast enough. Stop at the first. Okay? And that's it. Just don't be greedy. Don't try to make the string as large as possible. Go at the smaller one, the smaller possible one. We still need to find an F, and we still need to find a colon, but when you find the first colon, stop. And so what this does is this changes it so that what we match is from colon instead of going all the way. So the greedy match pushes as far as it can. The non-greedy match is satisfied with the first thing that meets the criterion of the string. So this is a little 3-character programming sequence. Any character, 1 or more times, and not greedy. if, for example, we were trying to solve the problem of pulling the email address out of a string, right, we can make good use of this non-blank character. And so the @ sign is just a character. And then we can say, I want at least one non-blank character before it and at least one non-blank character after it. So the way regular expressions does, it says, oh, okay, I find my @ sign, and I push in a greedy manner outwards as long as they're non-blank characters. Push, 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 push. Oops, stop. Push, 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 stop. Okay? So it's some number of non-blank characters, an @ sign, followed by some number of non-blank characters. So it's that's using greedy matching. It's doing that. Okay? And so this is where we get Stephen Marquard. We can and we would know if there wasn't there by the empty list, right? And so we'd get Stephen Marquard at uct.ac.za. Now, we can also fine-tune what we extract. Right? In the previous slide, we extracted whatever matched. Right? Whatever this matched, it looked across the whole string and found this thing, shoved it over, and gave us what it matched. But it's possible to make the match larger than what's extracted, to extract a subset of the match. And we'll see that on this next slide. Okay? So here's this same thing, which is an @ sign, followed and then with non-blank characters as far as the eye can see in either direction. But I'm going to add to it caret from space. So this has to be, start with, the first character has to be a caret. It's got to have the word from. It's got to have one space, and then immediately it's got to find this. Right? It's got to find a series of non-blanks, followed by an @ sign, followed by another series of one or more non-blanks. And then what we do, so this, if we didn't put these parentheses in, it would match, and we would get all of this data. It would go to here. But what we can do with the parentheses are part of the regular expression language, saying, okay, I want to match the whole thing. The parentheses aren't part of the string up here. I want to match the whole thing, but I only want to extract this part in parentheses. So this whole thing is a regular expression that's matched, and then the parenthesis part is what's retrieved for you. And so this makes it so that the only time it's going to look for @ signs are on lines that start with from space. It is going to want the immediate next character to be a non-blank, some number of non-blank characters followed by an @ sign, some number of non-blank characters, so it's going to stop right there, and it's only going to extract from here to here, and so we get out Stephen Marquard. But this is a pretty narrowly scoped thing because the first 4 characters have to be from space. And so that's a way to combine a stricter match even though you don't actually want all the data. So you can add those things all over the place. Okay? Okay. Then we can compare the different ways of extracting data. So if we look at how we extract the host name, remember how we did this many chapters ago. So we did a data.find, which says, oh, the first @ sign is a 21. So the first @ sign is a 21. Then we say we want to find the space after that. So that's the @ position, that's 31. And then we want to extract the data that's one beyond the @ up to, but not including the space. And that is the variable that we're going to print out host. And so we've extracted this bit of information, and out comes the host. Quite nice. Okay. We also saw another technique. And by the way, all these techniques are okay. All these techniques are fine. Another technique we saw once we sort of played with split and lists was what I call the double split version of this, where the first thing we do is we split that line. The first thing we do is we split the line, and then we know in blanks that the second thing, which is the sub 1, word sub 1, is the entire email address. Then this is the double split. We take the email address and we split it by an @ sign, and then we get a list of the pieces of the email address, the email name and the email host, and then we grab the sub 1 of that, and then we have the host. So that's the double split way of doing this, right? Now, in this, we still haven't done the from yet, but it is the double split way to do this. So if we think about how we would do this in a regular expression, okay, we're going to say, look through the string, find all. We're going to, here's the find all, and the regular expression exploded up says, look through the string for an at. Got an at. Then, start extracting, end extracting. And then this is another form of the this is one character. It's a single character, match any non-blank character and 0 or more of them. Okay? So find an at sign, start extracting, end extracting, match, this is one character. That is a set of possible matches, and that's some character, this means not. Okay, not a blank, that's a blank right there, that's a blank character right there. Not a blank, as many times as you want. You might want to turn that into a plus to guarantee at least one. So that might be better done as a plus right there. So this would probably make more sense as a plus to say I want at least, after the at sign, I want at least one non-blank character. And the parentheses simply say I don't want the at sign. So the at sign, I really want those non-blank characters after the at sign. Okay, so that's what I want to extract. So it's like, go find the at sign. Okay, great, found the at sign. Start extracting, look for non-blank characters, end extracting. So pull that part out and put it right there. Now an even cooler version of this, that you probably kind of imagined right away, is we say, you know what? I would like this first character, the first part of the line to be from with a blank, followed by any number of characters, followed by an at sign, so the at sign is real, then start extracting, then any number of non-blank characters, end extracting. So this is like 8 or 9 lines of Python all rolled into one thing. Okay. All right. So start at the beginning of the line, look for string from with a space, then skip a bunch of characters looking for an at sign. Skip characters until you encounter an at sign. Then start extracting. Match any non-blank, a single non-blank character. So this is kind of like one non-blank character. But once you suffix it with the asterisk, that changes it to be many non-blank characters. And then stop extracting. Okay? And so, so it's like find from followed by a space. Great. That's first part. Now throw away characters until you find an at sign. Then start extracting. Keep going with non-blank characters until you hit the first blank characters and pull that part out. Now the result is we get the exact same data, but with this added to it, we're much more narrow in the kind of things that we're looking for. And if we get noisy data that like something like meet at Joe's, right? We don't want that. That won't match, right? We want that to be like a false. And it allows us to sort of really fine-tune our matching and extracting. And this is just the beginning. They're very, very powerful. So the last thing that I will show you is sort of a program that is kind of like one of the programs that we did in a previous section, except now we're going to use regular expressions to do it. So if you remember, we had this thing where we're doing spam confidence, where we're looking for lines and and pulling this number out and then calculating either the average or the maximum or whatever. And so here is we import the regular expression library, we open the file. We're going to do this with appending to a list. We'll put the numbers in a list rather than doing the calculation in a loop. We strip the data. Now here's the key thing, right? We're going to have a regular expression that says look for the first character being X, followed by a dash, followed by all this. All this exactly has to match literally, followed by a colon. And then there's a space, and then we begin extracting, and we're looking for the digit 0 through 9 or a dot, and we're looking for one or more. And then we end extracting. So that's the parentheses are telling us what to pull out. So that just means that we're going to pull out those numbers, all the digits and the numbers, until we get something other, all the digits and the period, and we'll get something other than a digit and a period, and then we'll be done. Okay? And so this is going to pull those numbers out and give us back a list. Now the thing about it is we have to realize that sometimes this is not going to match, because we're sending every line, not just the ones that start with X. We're sending every line through this. And so we need to know when we didn't get a match. And that the way we know we didn't get a match is if the list, the number of items in the list that we got back is 0, then we're going to continue. So this is kind of our if, where we're searching for the needle in the haystack. But then once we find what we're looking for, the actual number that we're interested in is already sitting here in stuff sub 0. Okay? And then we convert it to a float, we append it, and then when the loop is all done, we print out the maximum. Okay? And so this is sort of encoding a number of things and ending up with a very solid and safe matching. So it's hard for this to find a line that's wrong. And you could even improve this a little bit to make it even a little tighter, where it would go find a number like 0.999. You could say, oh, it's all the numbers are 0 dot. So you could make this a little more precise, so it would even skip things. You can make it so it looks exactly the way you want it to look. So I emphasize that this is kind of a weird language, and you need some kind of thing. We talked about all these. We have the beginning of the line, we have the end of the line, matching any character, matching space characters, matching non-white space characters. Star is a modifier that says 0 or more times. Star question mark is a modifier that says 0 or more times non-greedy. Plus is 1 or more times. Plus question mark is 1 or more times non-greedy. When you have bracket syntax, it's a set. It's a single character that's in the listed set, so that's lowercase vowels. You can also have if the first character of this is a caret, that flips it, so that means everything except capital X, capital Y, capital Z. So it's everything that's not in the set, capital X, capital Y, capital Z. And then you can also put dashes in to represent ranges. Bracket A through Z and 0 through 9 in lowercase letters and digits will match. But again, this is a single character. Now you can put a plus or a star after these guys to make them happen more than one time. And you can even put them in twice. So if I wanted a 2-digit number, I could say 0-9, 0-9. Oops. This is one character, this is one character, and this is the possible things. So that's, 0, 0, 0 would match, 10 would match, 99 would match, etc. Okay? And then the parentheses are the things that if you are in the middle of a big long matching string and you don't want to extract the whole thing, you can limit the things you're extracting to the stuff that's just in there. With all these characters that have all this meaning, we have to have a way to match those characters. So $sign is the end of a line. But what if we're looking for something that actually has a $sign in the string? And that's what the backslash is for. So if you put the backslash in front of a otherwise meaningful character, it becomes the actual character. So this is saying match a $sign. Those two characters say match a $sign. And then this says one character that's 0 through 9 or a dot. And then we put the plus modifier to say at least one or more times. And so that sort of is a greedy, of course. So that will get us this and extract it, including the $sign. So the escape character is the backslash. Okay. So there we are. Now we're done. So this is a little bit cryptic. It's kind of a puzzle. It's kind of fun, and it's extremely powerful. And you don't have to know it. You don't have to learn it. But if you do, you'll find that it's very useful as we sort of dig through data and are trying to write things that are pretty quick. The thing I like about regular expressions is that they tend to be, if you write them well, they tend to be less sensitive to bad data. They tend to ignore data. You can put more detail. I exactly want this. Whereas if you're writing find and extract, you're making a lot of assumptions about the data. That's clean, and you're not going to miss hit on something. So, okay, well, good luck in your use of regular expressions, and we'll see you later.